Alrighty, so in this video I'm going to be doing a couple examples of how to solve certain exponential equations. In this case we can't use the common base, and we also can't convert it to logarithmic form because we do have an exponential function on both sides. So a really good strategy that you can use when you've got an exponent on both sides would be taking the log of your entire equation. Now, when you think of your log, it's really just any other type of normal function. So such as your square root or sine or cos. It's just as much of a function as any of those other ones are. So if we want to take the log of both sides, we're really just placing log around what's already there in our equation. So on the left-hand side, we're going to have log of 3 to the power of x plus 1. And on the right side, we're also taking the log of that. So 16 to the power of 2x. Okay, so first up, doesn't really look like a ton is going on. Now, we have a couple of log laws. So we know that we can manipulate these equations using the laws of logs. So the one thing that we can do is we know that any of the exponents can be moved to the beginning of the log. So why don't I move this x plus 1 to the front of my log, and that'll be the coefficient now of my log 3. Okay, so I'm just moving this exponent so that it's in front of the log. Now we can do the same thing on your right side. Let's bring the 2x in front of that log 16. So it doesn't really look like much still, but keep in mind that this log 3 is just a number, and log 16 is also just a number. So let's try working with this x plus 1 here. What if I distribute my x plus 1 times that log 3? So I'll have x log 3 and then plus 1 log 3. And your right side you can keep it the same, so 2x log 16. And again, we're still keeping in mind that log 3 is just a number, same with log 16. So we end up getting x times a number plus a number equals 2x times another number. And really that's nothing new from linear equations. So why don't we move everything with an x to one side? So this x log 3 part, we're going to move over to our right side of the equation. So on the left still we'll just have log 3. On our right, 2x times the log of 16. But then our x log 3 is coming over to the right side. So we're going to have minus x log 3. Now we're trying to isolate for x here. And I see that x is in both of my terms on the right. So why don't we try and factor that out? We can common factor out an x on our right side of the equation. So when the x comes out of there, I've got 2 log 16. And when the x comes out of here, I've just got my log of 3. Alright, so we're getting there. So don't forget log 3 is a number. All of this stuff at the end there, that's also just a number. So to get rid of it, why don't we divide it out? So we are going to have, if we divide both sides by log 3, or sorry, divide both sides by this section, we're going to have log 3 over 2 log 16 minus log 3. And so dividing both sides by that, it'll cancel it on the right, it comes over here, and we'll be left with x. Now all of this can go into your calculator, right? By taking the log at the beginning and not stating what base it is, we're assuming log 10. And then our log 16 can just be thrown into your calculator there at the end. Okay, so once this all goes into your calculator, you're going to have that x is about 0.2 and so on and so on. And again, rounding is up to you. You can leave it as a big long extended number, or you can round. So let's say x is approximately 0.247 and so on and so forth. Okay, so that's one of our kind of main other strategies of solving these exponential equations. is if we take the log, assuming log base 10 of both sides, we can use our laws of logs to move around what's happening with the exponents. Okay. So let's try another one here.